So in this video, we're going to learn how to multiply and divide rational expressions, that being fractions involving variables in them. And in our last video, we learned how to simplify, or just kind of cancel out pieces of rational expressions. So this is going to be the next logical step. Well, how do we deal with things when we're multiplying multiple fractions together? Now, before we do this, I always like to start out by showing you a problem with numbers. Let's say we had something like 3 over 4 times 5 over 3. So if you're multiplying fractions like normal, all you do is you multiply your top numbers and you multiply the bottom. You just go straight across. 3 times 5 makes it 15, and 4 times 3 makes it 12. From there you can reduce it, and you end up with 5 over 4. Not too crazy of a problem. Now, I always like to throw in right here a little shortcut that you could have done on this problem right here. It's not necessary with numbers, but it'll be really helpful later on when we deal with variables. Notice on my problem, I had a 3 in the top, and I had a 3 in the bottom. What's going to end up happening is I'm going to multiply these right here. So what I'm going to get on the top is 3 times 5 over 4 times 3, before I actually multiply the numbers together. Those 3's are going to cancel each other out. They don't break any arms right there. You can cancel them out, and you can just get 5 over 4. So if I see a 3 on the top and bottom, you know what I can also do is just cancel them out before I even multiply. So on my problem right here, 3's are just going to go away. I just get 5 over 4 right off the bat. It's kind of a little trick. That's not necessary on this sort of problem. You can just reduce later. But it will be more helpful in our new problems. So let me give you a problem here that looks really, really intense. This looks like an awful, awful problem to do. You have to realize, first of all, that you're going to do it the same way. You're just going to multiply straight across. If you multiply it as is right now, it's just going to be brutal. You're going to have to do FOIL, you're going to have x to the 4th, x to the 5th power. It's just a mess of a problem. So what I recommend we do right here, what you're going to want to do in any sort of problem like this, is really in the rest of our lessons together. If you see big pieces like this, factor them. Factor them and break them down. So I'm going to do the left side here, and maybe you can pause and try the right side yourself. But on the left side, with my top left, this guy right here, I know that I can take a 10x out. If I take a 10x out, I'm left with x minus 2 left over when you pull up 10x. On the bottom, I can have 40x to the 3rd and 80x squared. I can take out a 40x squared, pull it out, and then I have x minus 2 left over. So I'm actually going to pause right here for a second and just point out something. If you notice right here, I have an x minus 2 top and bottom. Those are going to cancel. That's great. Those just went away. So the only thing that's left over, like this part right here, for all we care about it, done. Doesn't matter anymore. We have a much simpler comparatively problem, 10x over 40x squared. So I'm going to leave this up here for now. Let's do the second one. Maybe even pause it and try it for yourself. Try factoring the right side. But when you do this, it's going to be 16x squared. We'll get an x plus 5 here. And when you factor the bottom rights, you get 6 on the outside, x plus 5. So nicely enough, the x plus 5's cancel as well. Stuff is just canceling everywhere. And like I used the trick on the last video, notice I have an x squared on the bottom and on the top. Even though they're on different sides of the problem, they're still going to cancel. Didn't break any arms there. So a lot of stuff went away. Now I'm just going to multiply what's left over. So on this side, I have the 10x and the 16. Those are going to make me a 160x. And on the bottom, I just have the 40 and the 6. That's going to be a 240. So you can go ahead and reduce that, and I'm thinking that's going to be 2/3 when you actually reduce your numbers. So you just get 2x over 3. And that's your final answer. Much, 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 much simpler than having to sit there and multiply those out with FOIL. Factor, and some stuff usually cancels out if it's a problem they give you. There's probably going to be stuff you can cross out. Our excluded values of this are our restrictions. X can't equal 2, because if x equaled 2, we would have divided by 0 right there. That would have been bad. X can't equal -5, because if you had a -5, you would have divided by 0 over on the right side. And finally, this one's always the one that kids miss. You have an x squared right there. Even though it canceled out, if you plug in a 0, that would have been bad for there. So those are the 3 numbers that x can't equal. And that's our problem. So let me give an example of a division problem as well. And at first glance on this one, it looks like nothing's going to cancel out. I mean, I don't see anything that matches. There's really not a lot of factoring you can do. The left side really can't be touched. Unfortunately, in this one, we have a division sign here, so I didn't even stop to think about that. That's different than our last one. But if you remember your rule, I'm going to make up a little problem off on the side here for division. Say we had 1/2 divided by 2/5. Remember, our rule for dividing fractions is keep, change, flip. Keep the first fraction, change to multiply, and you're going to flip the second fraction, make it a 5/2. Then you just go straight across. So we get 5/4. So I'm going to keep my first fraction the same, change to multiply, and I'm going to flip this second guy. And just so it matches all the other ones, I'm going to write this new part down here as -n plus 6. I'm going to turn it around. So I keep the first one, change the sign to multiply, flip the second fraction when you divide. That's the only difference there. Now it works like before. Now, luckily for us, I actually can do a little bit of factoring on the right side. 3 can be pulled out of that one, and there's an n minus 6 left over in the inside. And actually on the bottom side, it doesn't look like you can do anything, but I'm going to take out a -1. If you take out a -1, you're going to get n minus 6, which is really nice, because then they're just going to cancel out. These parts go away. So all that's left over on this one is going to be our 3. We have our first two pieces right here. So 3 over -1, and then n plus 9. This would be a totally fine answer if you wanted to leave it. If you wanted to distribute, you could. If you wanted to move the negative up top and make it -3 over just regular n plus 9, that's fine too. For our restrictions on this one, we have n can't equal -9, n can't equal 6, and I believe that is it. Those are our two values. So that is multiplication and division.